Okay, this is the Prelab video for the resistivity experiment. So when you come in, you'll have your workstation. This is an experiment where you each will individually have your own equipment, but you'll again work as a group. There isn't a whole lot of data collection to be done in this lab, so your time will not be spent collecting data, and it won't be frustrating to collect it. Data will come in very easily. Your time will be spent discussing with your group members and thinking through the concepts that we're trying to present in this lab. And this is the most concept-based lab that we have rather than a technical skills-based lab. And so when you come in, you'll have this board with wires pre-strung on it. It looks like a guitar, I guess. Doesn't sound very nice. But you'll have 5 different wires, and each of those wires have a different diameter. And the diameters of the wires is printed on the side of the board, so you'll be able to read what those are. And some of you will have a silver-looking metal, which is aluminum, and others of you will have a copper wires. So you'll either have 5 copper wires of different diameter, or you'll have 5 aluminum wires of different diameter, and you'll tell just by the color. Okay, so what we want to do is we want to pass current through each of these wires, and so to do that we'll use our DC power supply, and the way that you'll connect it is just to connect the alligator clips of the DC power supply to each end of the wire, and I'll just clip it right at the end of the wire, right near the bolt, but just on the wire itself directly, and I'll do that at both ends. And to operate, right now, if you can tell, I'm not sure you can read the display on this power supply, but it says on it USB no, meaning it used to have a USB plugged into the back of it, and it used to be under computer control, but now it isn't. And so it's kind of locked out. The front panel is locked out at this point. If this is the case for you, it may or may not be, but if it is, if you press the lock button and hold it down, it unlocks it, and it's in sort of normal manual operating mode. And so now I would just set this to the current that I want to set it to, something around 2 amps. And if I turn the output on, it's going to pass a current of 2 amps through this first wire that I've attached. And what you need to do at this point is measure the voltage across that wire. You can say, oh, well, the power supply is telling me what the voltage is on the top row. It's showing me, it's giving me 2 amps and 0.3 volts. But this is a horrible precision voltmeter here, so don't use that. Use your much better digital voltmeter. And it'll have its probes attached to it. And I guess what we're going to be doing is measuring DC voltage. So we're on this setting, and we'll just touch the probes near the ends of the wires, and we can get a measurement of the voltage. And it'll be much more precise than the voltage reading over here. So you'll go ahead and you'll do that for the 5 different diameters of wires. And then the exercises take you through the discussions and the understanding of what's happening with the electric fields, the electric potential, the power burnt up in these wires, electric potential energy, and you end up thinking about things like drift velocity. And all of these will sort of be kind of group discussion exercises where, because the data collection part is so straightforward, everyone should be reasonably up to speed together. And then after that, you'll spend a lot of time in the lab thinking and discussing and the rest of the exercises. There isn't much data collection after that first data collection exercise. So it's a bit of a different lab from that point of view. It's more a concept-based lab, as I said, but still I hope you find it rewarding and have fun. Good luck.